Well, hi, good morning. Thanks so much for joining me here in my shop. I'm getting a start on another radio. Very odd looking brick shaped radio here, which again, I don't know anything about its condition other than the word is it works. Obviously it's missing one knob. Looks like it's had a fair bit of play. I mean, you see this, somebody's been doing that a fair bit. I don't know what would cause all that damage, but I think this is probably pretty easy to make disappear. And even this stuff up here, and ultimately, without doing a lot of refinishing work, I think it's going to look just fine. But it is a bit of it's another ugly radio kind of, isn't it? So, Sparton. Unfortunately, there's a big sticker here. It's all worn out, but you can see the word caution on it. Okay, so I think, I'm tempted to just plug it in and see what happens, but let's not do that because that would be bad form. We should take a look. Take a look inside. Now, the thing is, I have been told it's a working radio, so I shouldn't be too cautious. It's one wire. Shoved it through here to kind of strain relieve it, I guess. So maybe this doesn't have an internal antenna at all. Oh, I think it does. I think I can see it in there. Virtually all these small radios are going to have a loop antenna, which is also forming the first tuning stage. Very, very important. So if you get an old radio like this and the back is missing, there's a chance you're missing a critical part in the radio. People might not have understood that. I didn't when I was a small kid, when I was playing around with these radios. I did not understand the significance of that. So this is bolted or screwed on with these two screws right to the chassis. These four corner screws were going into the cabinet. So we don't want to take these off. One big honker on the bottom there. Square. Stickers on the bottom. I mentioned in the last video about square-headed screwdrivers and how you only find these in Canada. I don't know if they're anywhere else in the world. Tubes, IF 455, model number 50450, and a sticker here in red. Now, what would they put in red? Warning! Any person, something or other, or operating this receiving set without first having obtained a license from the Minister of Transport of Canada is liable upon summary conviction to a fine not exceeding $25, and the said receiving set may be forfeited to His Majesty by order of the Minister, for such disposal as the Minister may direct. And that's from the Radio Act, 1938, I think it says. Well, on pain of being charged with a crime, I am going to carry on here. Good, because I don't have a license. I have a ham radio license. How about that? I have a CB license too. Yes, I have a CB license. I actually have CB call signs. Okay, take a look inside. Oh, sticker there. Canadian Cabinets Furniture Limited. That's a metal plate. Much else going on in there. Solid as can be. It's so simple. Such a simple box. That's probably one of the reasons why it's still with us. Okay, now what came out of it? Light bulb here that's come loose. Yeah, so it looks like there was just a clamping or friction fit of metal against this plastic bulb. housing, if you like, or bulb socket, and I think the socket's probably shrunk a bit. It's just come out. And yes, as I was a little bit concerned, it's kind of packed tight in there. It's packed really tight, in fact. Look at all those tubes jammed in there. There's 3 of them jammed tight together there. That's definitely not the best arrangement. You know, mutual heating effect. And the speaker's cracked all over the place here. It's got cracks, cracks, cracks. And it's also got some warping in here. Yeah. So speaker might be a problem already. I want to start right off with testing the speaker. If the speaker is crap, I'm not going to get much out of the radio. That's interesting. It's got a bottom plate, but it's got this port through it and something riveted there. It looks like that's probably some kind of adjustment you get access to in there. Oh no, that's the screw. That's where the screw comes in from underneath the... that's what holds the whole radio. Look how small it is, eh? Wow. Big capacitor here. And the antenna on the back with a capacitor. Here, this is probably the blocker for the wire that's coming out. And blocker of what? This is a 5-tube radio with a non-polarized plug and no transformer. So there's every chance in the world. And when you plug it in, 50% chance in the world. As soon as you plug this in, the chassis is live at 120. And if that doesn't happen, when you turn it on, then it's live at 120. So some other signs of that is these were protruding from the cabinet, weren't they? So that just tells you the vintage of the radio. It already has this live chassis danger, but they hadn't yet pushed manufacturers to recess these inside the cabinet. So when you pull the knobs off, these aren't sticking out. And so this is a non-conductive post here that they've attached this with, so this screw would not be on the chassis. And that big screw, if you look again, there's some kind of unusual material here. There's something going on here, so it doesn't look like it, but just maybe the screw is not actually making metal contact with the can. I'm not sure. So, what are we going to do here? We can pretty much bet everything is brand new inside, or not brand new, brand old inside here. Nothing has been done to this radio ever. Yet the word is it works. If we do want to find out what the speaker sounds like right away. Okay, let's try turning it on. See what happens. Nothing. We gotta plug it in. Come on. Just kidding around there. Just kidding around. Okay, since this is video number 1 of a series, and some of you may be viewing my videos for the first time, just to let you know, you're watching me do this stuff right off the top of my head, so to speak. I don't rehearse this thing. There's no script. There's nothing. Right? I turn the cameras on. I go to work. Stuff happens. In my shop, I've taken steps to make myself safe in here, and I'm going to describe them very briefly, but if you are doing this kind of work on your own, it's your business to make yourself safe. And it's complicated enough that it's a little difficult for anybody to just explain in a matter of a couple of minutes how to stay safe in a shop like this, other than to say, know what is going on. Know what is going on. And what is going on in here. So this outlet I've got the radio plugged into, this box. You can see it's actually plugged into this extension cord. And you can see the third prong is just sticking out in space here. There's no third prong connection here. There isn't even one brought forward. This is only a 2-wire extension cord here. This cord is plugged into a transformer. It does not go into the wall directly. It goes through a transformer. And that provides ground isolation for the item I'm working on. What that means is I cannot or should not be able to get a shock by plugging this in any old way, turning this on or off any old way, putting my hand right on this chassis and sticking my foot right on the floor, which I'm not going to do. But in other circumstances, if this is plugged into the wall and you do exactly what I said, you're taking your life in your hands at that point. Definitely. Through your feet, from your hands. So there is a danger here on these radios. This is called a 5-tube radio, sometimes called an All-American 5 or an AA5, but they're not all-American. Many of them are Canadian and other countries too. So as soon as you see a 5-tube radio and some of the numbers on the tubes are 50 this and 35 that, it's time to say this radio is dangerous and I better read up on hot chassis danger. So just type that into Google and you can read some good stuff on lots of websites. One of them is a place I buy my capacitors at, Just Radios. Go to Just Radios, they have a few pages on this kind of stuff, very helpful. So if you don't know what I'm talking about and you're about to start working on one of these radios, stop and find out what the hot chassis problem is. There you go. Now another thing I'm going to do, or I have in my shop, is a very simple way to power up items that might have a short circuit in them. I mean, if you did that in a regular house, just plug something in the wall, turn it on, and there's a dead short in it, you're counting on your fuse or your house circuit breaker to operate under those circumstances. It's actually not necessarily guaranteed they will operate, and if they don't, probably what you would end up with then, you have a partial short, a fire is coming. Something like that is going to come. So what I do, because I don't know if there's a short in this radio, as much as I doubt it very, very much, is I run the power that's going to reach this radio through a light bulb. See these two light bulbs here? So if I throw my control panel switches the right way, any electricity reaching this radio is going through this light bulb on the way. If this thing tries to draw a lot of power because it has a short in it or something seriously wrong, the light will come on bright because of the power being drawn through it. And that will restrict the amount of power that reaches the radio. And also, the bright light tells me something's going wrong. That's probably the main part. So there's a little more to the dim bulb thing. Again, if you want to know more about this, I'm not going to explain it any further than that, other than to say I utilize it and I like it a lot. Look up dim bulb safety or dim bulb shop supply or something like that on Google and read what people are doing. Now I have a little control panel here. I'm sorry for those of you who watch so many of my videos, you know exactly what I'm doing. So explaining this is a little dry. That energizes the power. It's not quite on yet. If I flip the switch down, the light is in the circuit. If I flip the switch up, then it's straight to that transformer I was talking about, and this thing will get its full power at that point. This guy won't draw very much power, even if it's working. When it's working properly, it doesn't draw much power, so it's not going to fire this light bulb up at all, probably. So my expectation is I'm going to throw the switch. Numbers are going to start showing up over here. We're going to do it with the radio switched off first. Let's do that. We can do that. Okay, I was gambling that the on-off switch worked, which it did. So now we can get a look at the supply voltage here. 123 volts. That's a little lower than it is on some days. Now, I'm going to turn the radio on. When I do, this voltage should drop a bit from current being drawn in the radio. This bulb might come on a little bit. Here we go. Or maybe the light's going to come on full blast. There's something wrong in here and I've got my hand on it. So I'm going to cut the power, turn the switch, power it up from up here. There we go. So you see the light come on. See the numbers drop to 100 volts. So the light came on here. Hey, that's kind of neat. Good thing. And now we're waiting to hear what happens. All original. Here it comes. She's a Hummer. Nothing going on with the volume. Okay, no surprise there. So almost certainly what's going on is this filter capacitor has failed. It's too old now, can't do its job anymore, and he's got to be replaced with some new filter capacitors. After that, this radio may actually work as it is, or there may be a whole series of more difficulties, probably all related to weak or bad capacitor. So let's cut the power here. Plug out, we'll take the bottom off. Green handled Roberts. These square-headed Roberts Canadian screws come in 4 sizes. Yellow, green, red, and black. Green and red. If you're Canadian, you almost certainly have a green and red square screwdriver in your house. You won't be doing much without it. These are not obscure screws in Canada. These are in command in Canada. These are the screws you find in all kinds of things. Square head. Watch. Yeah, bad demo, Jim. Yeah. Oh my gosh, that screw just went 5 miles in the back of my shop here. So, there we go. It's the first time I learned that this screwdriver was not universal. I couldn't believe it. Go off. Look at that. So, see, this is a what kind of material is that? That's a bunch of laminated something that feels. This feels like more metal. I'm thinking that's an insulating method for the screw. Can't say I've ever seen this before. Yeah, it has some kind of insulative material, but it really feels like metal. Huh. You can see where I scratched it here, and it really looks like metal. Okay, fascinating. Screw hole. And what do we got in here? Oh, someone's been in here. This doesn't look original. That doesn't look original. I think it is though, and same with this. Boy, oh boy, it's really jammed in there. Not a lot of parts again. So these look like replacements. This one, and this one. Let me get a closer look in there and really see what's going on. Okay, let's take a little trip through this radio here, close up, and see what's up here. Because it's been in a closed metal can, it's going to be in a little better shape than it would be if there wasn't a can underneath it. Wow, this is a really suspicious capacitor here. This just doesn't look... This does not look like the right vintage. Bit of inconsistency here in how this is done. So over here the wires are all covered. The lead wires from the components. They have mostly this brown colored cover on it. I mean, you can bet this is original. And so this is original. So this is the original cover. You can see it all over the place in here. Come down here, there's more of it. But look at that black capacitor with those leads sticking out. Looks to me like they would have covered those. They would have chosen to cover those. So again, this looks like a replacement. capacitor. And some shielded wire there. Well, that looks like something's happened to it. That looks like something's happened to that. It doesn't look soldered, eh? Huh? Maybe it is. When it looks like I'm being really clumsy with the tools, it's usually because I'm looking in my TV, screen. No, it's soldered in there, I think. Sure looks like, well, you know, maybe somebody took this antenna off at one time and then they disconnected that wire to do it. The other wire is this green one here. Has it been resoldered? Kind of looks like it. So I think somebody's taken the antenna right off the back of this radio. But they chose to leave these wax capacitors, so you know, if that was done any time in the last 20 years by someone like me, these capacitors would be gone. The paper ones, I'm pretty sure. Okay, so nothing really leaping out here at me other than these capacitors and the stories I'm making up about them. Let's look at what's going to happen when we try to augment this. We have the big guy. So here's the big guy right here. Right here. Right on, oh, yeah, right where? Right under all that. He's right under all that. Oh my gosh. Ha 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 ha. So there are easy ways of doing this. No, I don't think there are. There are various hard ways of doing this. Is it really down there? Oh my gosh, it is. Right down there. Let's blast in some more light. Maybe I'm just not seeing something. So what we can do in a case like this is there's probably wires hooked up to the capacitor, and the wires are going to go somewhere, obviously. And where they go could afford an opportunity to make a connection. The other thing is that German, yeah, come on, this can't be original. Germany. Look at the wire cover. It's this black stuff. It's not the same orange stuff. So, you know, it almost looks like a junk box repair here with these three different capacitors, because two of them are 0.01 and they look totally different. And what about this one? What about the one from Germany? Send it all the way in from Germany. Frankly, these brown guys are often bad. 0.00, I can't really read it. Okay, so what I think that means, I'm going to be replacing these capacitors. So they're going to come out. That's going to create space and access to get at the filter capacitor. I need a place to put the new filter capacitors. This original one, it's riveted right onto the chassis, so it's a bit of a mess to get it off. And you can't even access the rivets. Well, yeah, there's one up there. And you drill it out. It's only two capacitors, I think, in this can. Two sections. You can fit in two capacitors, about each one about the size of that brown guy there. A lot of space up in here. The capacitors are in low, very, very low impedance circuits, these filter capacitors, so you can run wires to them and stuff like that. So I could relocate them. The other problem is and this happens in all these radios when you go to do this, the wiring goes to those capacitor terminals down there. Look at that, look at that, look at that resistor. It's tucked right up against the terminal. Oh my gosh, is it really? Do you know what I'm pointing at? Oh, what I'm pointing at. I'm not pointing at anything. I am talking about that one. It's right on one of those terminals. And if I go in there with a pair of cutters, I'm going to ruin that resistor. So again, probably all part of low impedance stuff. We can move it all around without too much concern. Another problem is this resistor here. That's a very high wattage resistor, part of the filter, probably connected between the positive terminals of the filter capacitors. That's got to go somewhere. Right now, it's like a lot of stuff is on those terminals. That's always the case in these radios. And losing those terminals just creates quite a challenge. I like to maintain the terminals. Now, there is a technique I have seen or heard about. Basically, you remove the leads from the terminals and then you attach an insulated terminal extension. So you still have new terminals roughly in the same location. You know what I'm talking about? These terminals down here, this thing. So you have new terminals roughly in the same location. All the wires and everything can reach the new insulated or isolated terminals. And you utilize the physical strength of the existing capacitor to hold the terminal in place. It's a great idea. I've never tried it. In this radio, okay, let's look at the power cord. Never mind all that. So this is almost certainly a replaced power cord here. Probably the guy who did any work in here would have done this cord too. The cord comes over here. What exactly is it hooking up to there? That's probably the rectifier tube right there. Well, I'm pretty certain it's a rectifier tube. And the other lead goes around and goes way down in there. So I think this cord is perfectly fine. I don't have to think about changing it. It's a tiny little plug. Hardly room there to get your fingers on it. You'd be saving 1/4 of a cent on every plug because they made them so small. They manufactured them. Okay, what's coming to mind here? Something should come to mind. What's coming to mind is I have to get rid of these paper capacitors. I should get rid of these molded ones also, even though they look nice. Well, like that black one doesn't look so great. So you might have a crack right along the seam there. Maybe not. Get rid of those. Taking those out temporarily frees up a lot of space. You want to put these back where they are, pretty much in the same position, because we don't know offhand how critical any one of these might be to setting up an oscillation or feedback of some sort or something like that. But so the power capacitors can go in that space can go up in here. Now I have to bring the power capacitor leads back if I want to try to utilize these terminals. And another choice I have is to leave the old capacitor in the circuit. It's a choice I have. I think I'm going to choose to get rid of it. So another possibility here is maintain all the connections as they exist on these terminals. Cut them free from the old capacitor and let the terminals float around in there. To get enough stuff soldered up to them, they can be held fairly stiffly in place. Another option is to move forward a distance and then reconsider everything. Like cut these capacitors out of the way and then look again. Let me get a couple of those filter capacitors and see what they look like in there. And I'm out of them. Son of a gun, I'm out of. Well, it's kind of. Well, these are roughly the same size. Let us look and see what happens when you try to stick one of these in here. See, that looks nice. Sitting like this. next thing we got to do is figure out, are they using the chassis as a B minus return, or are they doing the or do they have a B minus wire in here? So here's a chassis connection. It's over here near the front end of the radio. The tuning capacitor is right there. The rivet, is the rivet soldered? They don't seem to have soldered the rivet. A little unusual that they wouldn't solder the rivet to the chassis, just to make it really, really secure. Now, is there anything else connected to the chassis in this radio? So I think we're looking at a piece of insulation under here. We are. No, that's not insulated, is it? Well, that's right onto the chassis, and the rivet goes through to here, and this shield, so the shield is connected to the chassis, not to the B minus. You can understand why. If you're going to run a bare shielded wire through your radio, it's going to touch the chassis all over the place. So, but B minus won't be associated with that. Looking very carefully for anything that's touching the chassis here. We have some metal tubes in this. No, I don't think they're all glass tubes in this radio. That's pretty close. I'm looking at the terminal on that tube socket. So how close it is to the chassis. I think it's touching. Nope, there's clearance there. Okay, going back to the business area here. Just see if I can get a little better lighting on the topic here. Now that big high wattage resistor in there could be bad. Can easily have gone high. Now I'm going to get the schematic for this. We're going to take a look at the schematic before I do any more. I want to know a little more about how the chassis is treated and see it on the schematic. Well, we've got a beautiful schematic here to look at. Thank you to whoever redrew this. Clearly you were a drafts person, I can tell from the printing. This is all hand printed, done beautifully. Lovely layout. Okay, what's this tell us? So first of all, you want to hook up an external antenna. It's through this capacitor and a coil. That's a little unusual, the coil here. And from there, the external antenna would feed around through here, right onto this third grid of the converter tube. So if we hook up on the outside antenna terminal, which there isn't one, there's a wire. If we hook up to the wire, we're hooking up to the grid through this capacitor. The tuning section of the capacitor, the non-local oscillator section of the tuning capacitor, is working against this coil. The result is fed onto this grid. Meets up with the local oscillator here on grid 1. Very, very straightforward radio. The combination is presented to the first IF transformer. The 455 component does not get killed by the non-resonance of the transformer. This transformer looks like a short circuit or a lousy short circuit to all frequencies other than 455. So 455 gets a free ride, shows up over here, gets boosted by the 12BA6, and through this transformer, same deal, comes out the other side, meets up with the diodes here. They're paralleled in this radio. Yeah, this is where the shielded cable is running. Right up in here. I notice there's no shield here or in this area that I could see, just on this piece. Okay. I'm humming because I think this is a low impedance circuit right in this area. It's probably a fair size capacitor down to, this has got to be the B minus here, and B plus, B plus, B plus, B plus is here along this line. He's used, so this is a real draftsman. He's put dots where wires are crossing, because you could ask yourself, is there a connection there? But with a dot, you know it. But here, where wires must be connected, there's no reason to put a dot. So this guy is drawing the schematic for people who are familiar with reading these schematics, for professional schematic readers. This is a really nice one. Here they're indicating with the word case that this is a two-part single capacitor. I mean, look at it. It looks like it, doesn't it? They didn't write the values there. Where are the values on everything? Okay, so there must be another page to this. I'm sure there is. Okay, curious how they did that. Oh, in on pin 1, out on pin 7, which are internally connected in this tube. Okay, let's follow the AVC situation. Come down through R4 and R5. R5 is probably very large. R4 is probably not so large. The resulting DC voltage, I think it's coming down this way. R3 is probably very large, a couple mega ohms, something like that. On this side, you have very high impedance circuits leading to grids. Yep. Yep. The resistors here are large. This resistor would be large too, but there's not really any current flowing through it to any DC current or anything like that to cause a voltage drop. Of course, the DC voltage derived here is then utilized as AVC control for controlling the gain of these two tubes. So here's the, I'm really not sure what this capacitor is for here. It's on the output of the triode. I think it's to eat away any RF that has somehow made it all the way to here. The RF is supposed to die at this point. It's sucked down through this capacitor and thrown away here. And a little more here. In case some gets through here, come this way. In fact, this is really a pi filter here when you look at it. These two capacitors and a resistor. Kind of a pi? No, it's not a pi because this is connected right together. Pi? No. But still, I think this is still trying to get rid of RF. This is trying to block DC from going on its way with the audio. Look at another one here. So that's unusual. Why would they do that? I'd have one here and one here. You got me. So if you allow DC, well, I guess they didn't want DC going through here. There's a good reason to not have DC going through here. They provided the voltage divider resistor here. So in some radios, this resistor doesn't exist. This capacitor doesn't exist. And this resistor is connected to that resistor, forming a voltage divider, which gives the designer an opportunity to control the amount of AVC voltage that's going to come out by just setting the values of the two resistors. And for some reason they've used a voltage divider separate without using this. The reason you don't want DC going through here, you don't want DC going through here. This is really where you don't want it going through. Because no matter what you do, if there's DC flowing through here, when you turn the volume, you're going to hear, it doesn't matter how much cleaning you do, you're going to hear that. And so that's this guy's job. And this is just the fairly large resistor to bleed off charge that might build on the grid. Now, so this guy, he's going to have a cathode resistor, almost certainly R10 here, probably a couple hundred ohms, and it doesn't appear to be bypassed.
This would be a fairly large resistor here, again bleeding down any charge that builds on the grid. No feedback, like a distortion control feedback in here. There's no wire coming back from the speaker or anything. It's not that serious a radio. What's going on in the power supply here? So we have a dropper resistor here. Why would that be? Interesting enough, look at this. This is how efficient this draftsman was. He just dropped the 12s here so he could fit this on the page properly and make it look nice. Hey, wait a minute, there's a tube missing. Oh, here it is here. So you got a 35 and a 50, and that's 85, and then 36 on top of 85. Can I add 36 to 85? I can add 35 to 85. That's the same as adding 30 to 90. 120. 120. So what's this guy doing here? If the heater string can drop 120 across it, what's he for? R12. So this capacitor is right across the power line here. It does a couple things, so I've heard. One of them is any radio interference coming along from your house wiring. Maybe you've got a mile-long extension cord. This radio is plugged into a mile-long extension cord. This should snuff it out. Any RF at this point should be snuffed out. The other thing it does, I've heard, and I'm going to repeat this for the second time. I don't know if it's really true. If we track back, I don't think it's true. The idea is that there's no ground here. If this antenna is just working against the chassis, and you can get it to work better if you can give it a better quote ground or something to work into or against. That's the way I put it. And so this capacitor gives some access to the antenna signal to the rest of the hydro system and introduces it in such a way that it helps the antenna system work better. Now, I don't know if that's really true or not, but one thing for sure, when you look at that, it's right across the power line. So if this capacitor were to short out inside, probably it would just go and a little puff of smoke and that'd be the end of that. But it might not. It might develop a short circuit here sufficient to draw enough current to start it on fire. There's nothing slowing it down. This is plugged into a nuclear power plant, actually 3 of them in parallel in Ontario, and with Niagara Falls pushing along too. So a lot of power available here. I should change this with a more reliable capacitor. I have special capacitors for this position that apparently are much safer. And that's about the end of the story here with this. I'm interested in R12. Let me see if I can find the component list for this. Wow, we've ended up with a great page of information here. String guide. I'm looking at the large part placement diagram up here in the top left. C5 omitted. Oh, so this is this schematic. This information fits a number of radios. You can see them here: A150, 250. I got the 450 here. So this is about the 450. C5 omitted. 47, maybe different sizes or something. I'm not sure what they're getting at here, but something's going on. 500,000 ohm volume control. R12 omitted. R12 omitted. Which one was that? R12. L1 omitted. L1 was that coil on the antenna. Oscillator coil. R12. So it wasn't R12. Let's see if I can find where. What did I do with it? R12. Yeah, it's this one. Maybe in the other radios, one of these tubes is not, like this might not be a 50. Maybe this is a 35B5. This is a B5, 50B5, okay? Just pounding that in my head. I had C5 in my head. Okay, the other one again. These models, we won't bother reading that. Electrical alignment. Adjust signal generator 455 connect antenna terminal dial 1500. Adjust IF no slide. Top to bottom. Iron cores. Fiber trimmer stick. A fiber trimmer stick with a screwdriver tip is preferred. Signal generator, blah blah blah. Okay, everything's straight. No, base plate on chassis. Oh, during the alignment, you should have this plate on. During the alignment. Now, here's the part list. What was that R12 anyway? R12 was going to be 39 ohms. That's like another heater. There's R10 at 150. R10, wasn't that the, was that the 5 watts? So this must be in the power supply, the 5 watt. Look for another small resistor. What? There's no other small resistor. 1800, R11, 1 watt. So 1800, is that what's in the R11? Let's take a look. R11. R10. Here's R11. So R11 is the power supply, and R10 is the cathode resistor here. R10. Let's look again. R10 cathode. R10 cathode. Yeah. Okay. 150 on the cathode, and then 1800 in the. Oh, that says 0.5 watts. That's what happened. 0.5 watts. 1800 in the between the capacitor terminals. Anything else happening here that's bizarre? I don't think so. The filter capacitors are, where are they here? Trimmer, patter. Here we are. 40. So 2 40s. Is there any other electrolytic capacitor? I didn't see one. I don't see one in the list. So that's all there is. Just that. 2 40s. Okay, we're going to extract any more information out of this thing. Today is February 7th. Friday, February 7th. Good.
So the potential to get into a jackpot with this radio is really, really high. And what I mean by that, a jackpot is a term I learned from linemen who I used to work around. I never worked with linemen, but I worked around them in the power company. And for them, a jackpot was a situation that you get into before you know it, and once you're in it, a disaster is guaranteed. So, and in the case of a lineman, of course, they're talking about falling or injury, electrocution, burns. I mean, serious stuff happens to linemen. So, a jackpot. So how would that work here? So if I rushed into working on this radio, and I dug away in here with a plan in mind, and halfway through digging in here I realized my plan is crap, and I've dug myself into a situation I don't know how to get out of. And as I proceed along, the situation gets worse and worse. And what am I talking about? Cutting wires I shouldn't cut, and trying to do things that ultimately won't fit, and all kinds of stuff. And the situation just gets worse and worse and worse. That would be a jackpot. So I've been there before. Don't want to be there this time. So I've made a pictorial diagram of the capacitor I want to work on, and I've shown pictorially how the wires run from the terminals and how everything's connected up to make me fully aware of what is going on in this radio. So let's take another look in here. So I've pulled back this capacitor, which has a funny, just like a chip on the shell here. It doesn't look like much more than that. But I pulled it out of the way. I moved this one up and out of the way. And get a little more room to look in there and examine the connections and make sure I'm seeing what's really there. Now the resistor I'm talking about that is right up against the terminal is this guy right here. Yeah, that guy. Right up hard against the terminal. So I want to cut that away. I'm going to do something with that. What am I going to do with it? Why is it up so tight on the terminal? Could be no reason at all. Could just be that's a handy way to build a radio. There's no electrical reason. And these are the center posts on these tube sockets.
which often nothing goes on with them. But here they're busy on this radio. Look at this one. It's got connections all over the place. Look at that guy. Again, the center terminal on the tube. So they've just turned that into sort of the B plus, B minus terminal points for making connections. Even this one here. So this is an extremely efficient radio when it comes to its design and its wiring. It looks a little like a spaghetti jungle, but really, the more I look at this, the more I realize that they took a lot of opportunity to shrink down as much as possible. Okay, so here I am after lunch now, and I've managed to make my nice diagram here of how I'm going to go from this to this. So let me just review this for my own sake and see if I made any stupid mistakes. So the new capacitors are going to be sitting over here, which in the radio is kind of over in this area. That's what I'm planning there. I'm going to take the negatives from the 250s, join them, and then bring an extension wire from there up to this terminal in the center of the tube here, the tube socket. So this is the B minus location. I'm going to leave this existing wire that comes over and attaches to the can of the existing capacitor. I'm going to leave it there because there's a nice wire going up here. I don't want to fool with this. I just leave it. That'll be fine. The fact that the can is still connected won't mean anything. The two terminals that are here, I will cut all the wires off and they'll be cleared right off. So that shouldn't cause any kind of problem. Then the resistor that is currently right basically between the two capacitors right here. I'll put a new, I guess probably a 1 watt or so resistor right in here. I'll make this up as kind of a unit or a package to be installed. And if we follow one positive side here, see that this goes out to the output transformer for the speaker. So that wire currently is running in here, and I'm hoping I can cut it, pull it back out, and then lay the same wire back in over to here where I want it to go. Chances are this isn't going to work. Chances are the wire is just going, the insulation is going to crack right off. It's really snaked inside the radio, so it's a bit of a long shot. So plan B, because this wire, I really haven't checked actually, but I think it just goes right up, right into the transformer. In fact, this wire is from the transformer and its manufacturer. So there's no terminal going back this way. So at some point I'd have to just cut the wire and piece in a new piece of wire to run over here if it turns out to be too stiff. And that's fairly doable. Everything's tight in here, so, but I think it's doable. Then there is a wire, a red wire running from here. Here it is here. So the rectifier. So that wire will become this wire. Be the same piece of wire, just cut shorter and reattached. And then we have this resistor, which in the radio is tucked right up on this terminal. Not the way I've shown here. It's right up against the terminal. Here it is here, renewed, and I'm just showing it sticking out there. I don't know why you want it pushed right up against the terminal. I think that's a red herring. And I think that about covers it. If I can manage to wire this up the way I show it, that's great. I think that'll work. Great. Okay, I got my little capacitor package done with the, I had to use a 2000 ohm resistor instead of 1800 in there. Now we're going to find out if this really fits in the radio or not. Or is my plan finished already? Let's take a look and see here what we can see. Okay, so I was hoping to kind of stick them in like that. Hey, that's going to work.
Okay, and I'm just sliding up the heat shrink here. Okay, well, a little jackpot's happened here. There's another wire in here I didn't account for. That is now exposed and visible. It's a red wire running from there, runs over there. Now this red wire turned out to be pretty flexible. I cleaned off the insulation okay. Maybe I can do the same with that one. Okay, there is the terminal. Red wire and resistor. Here comes the cutters. I think. Here they come. Okay, maybe a resistor first here. Sounds like something got chopped. What all did I get? So let me get a grip of that resistor there now. Pull them out. Okay. Part of it came out. Now, did I get the red wire? No. Wow. Missed. There, that must be it. Yep. Okay, so I'm just slowly making my way ahead here, and what's happening is the field of work is expanding, so I've had to cut off this capacitor here. The concern for me is getting confused, frankly. I get too many things on the go at the same time. It just increases more and more the odds of an error happening, but that's what happens with these jobs. They have a way of getting bigger. I think that's generally true of just about everything, isn't it, really? They usually call that cost overruns, but really it was lack of foresight. That's really what it was. Good show. I arrested an error in the making. Right, so this red wire goes to the other end down there. Down where the resistor is. Oh boy. Just gonna slide right in. Okay, so I think I've got the radio back together and ready to operate. In fact, just push these down a little bit. Maybe we'll take a look at what I did with the close-up camera. But I installed these two capacitors, resistor there, these two yellow capacitors also. That will give us a couple guys to test here too. This one, where's the other guy? He's around somewhere. So let me take a close look at this, just to double check. So strands back there. Oh, those are the cut ones. When I cut off a bunch of the strands from that wire. That's what that is. Okay. What's that? Oh, that's right. Yeah, that's okay. That's okay. That soldered under the sleeve there. This was a real tough one back here. It looks good. Okay. solid. Good. So there's still, as you can see, these potentially bad capacitor, most likely a bad capacitor, and another couple down here. And, but I think we're ready to try it again. This time the radio may actually succeed in operating. I've made numerous changes to it, fooled right around in the power supply. If I've done something wrong or introduced a short in some way, I gotta be ready for it. I think I have a tube out also. I'm not gonna get too far with the tube out. Here, little tubey. There you are. So that wire I put in here is now ready to lay up against the output tube. That's not the best idea. That's why those wires were, the insulation was cracking on them. They're getting cooked right there. Okay, but this radio is not going to be on for hours and hours a day. Nothing like that's going to happen. So, okay, let's give this guy a try. Got him plugged in. There we go. His switch is off. So we're starting with the switch off. Have your eye on the dim bulbs back there. So far, so good. Okay, I'm going to power off there. Switch on. This time, I got to be ready. If the bulb comes on full bright, then I booped it up bad. Here we go. No, perfect. It's just what it's supposed to do. Excellent. 106 volts over here. Turn it up. What do we hear? Okay, nothing. Well, I think what I was hearing there at the end, where I was stopping, was actually the effect of a radio station being tuned in by the radio. We can't hear any of the audio coming from it, and well, I'd say the radio needs a little more work. I think that's what I would say at this point. So we're just going to carry on with the capacitors next, and once those are done, we'll see what we've got. So far, the hum though, the hum is gone.